Hey, what's up? It's Jake from Nimbus DevOps, and now we're going to go past the whole idea of this next function concept in a generator. And I made this file first n squares manual method, and we'll go ahead and give you an example in here. So, generator objects are based on an iteration protocol. We will get into object-oriented programming, decorators, and iterators after I'm done with generators. So don't worry about that. I'll get into more examples. For now, you just need to know how next works. So what happens when you call the next generator is that calling generator next, so like literally like underscore underscore next, right? Like calling that is what you're doing. And remember, a method is just a function that belongs to an object. Like it's an object has these properties. It has a value, an ID. It has a method. So this would be its action, right? It's a function that belongs to an object. So all objects in Python can have special methods, and next is one of these. Its purpose is to return the next element of the iteration, or to raise a stop iteration when the iteration is over and there are no more elements to return. So I guess a little special note too, if an object's special methods are also called magic methods or dunder, which is the double underscore methods. So if you ever wondered what this double underscore thing is, it's dunder next dunder and then open and close parentheses. Fun little fact. So when you write a generator function, Python automatically transforms it into an object. It's pretty similar to an iterator. So when we call the next generator, it's transformed in generator dot dunder next dunder. Ooh, that was almost a dunder dunder. So it calls this, it's transformed into that. So let's look at generating squares and start here. So if we go back to when we did this gen n, and then I said for x in range n, we just want to yield x squared, right? Something like that. And then we're gonna take, hey, go all the way over. All right, so we're gonna go squares equals get squares gen, and that'll give us our object at location, whatever memory block. But we'll go ahead and stick a number in here like 3, and then I'll show you, we're gonna print, and then we'll go squares dot, and then let's call it special function. So you see all these special ones that we have here? There's all these ones. We're gonna use next. Okay, and then we're just gonna be like, bloop, give me that. And I'm just gonna print this 4 times, but on the 4th one, what we should see is from my gen, this problem, right? So we should see this problem. So let's try this and see what happens. Exit clear Python first. All right, 0, 1, 4, and then when we get to 3, or well, in this case, I guess 3, it says, because we only have 3 items to iterate over, that we reached a stop iteration. But you'll notice that last time I just did print and then I used the next function, right? So here I'm just showing you exactly what kind of special object, special method it's using under the hood. So the result is exactly the same as the previous time that I did this. Only this time, instead of using next like this next squares, instead of doing that, I used squares dot and then the special method. But generator objects have 3 other methods that allow you to control their behavior. There's a send, a throw, and a close. And you can kind of see this. So like if you go squares dot, and there's like all these things, right? If I go underscore underscore, you can see all these little special methods that it has. So they actually have a lot of other ones. But what I'm talking about Specifically is like throw, which it doesn't show here, does it? No, but if I type th throw, something like that, you can see some things. But so you can raise an exception within the generator and close it. It's kind of an advanced use case, so you probably won't see this, but it's good to know that it's there, at least so that you're like, I remember hearing about this once. So here's like, I'll just do like one example. So let me get rid of this stuff, and we're going to define a counter. Actually, let me create a new file. Let's just save this, close that. Let's create a new file, and we'll call this gen.send.preparation.py. So what I'm going to do here is I'm going to define a counter, and I'm going to say start equals 0, and then n equals start, and then from here we'll say while true, we want to do something. We want to yield n and increment n, and then here I'm going to say c equals, and then call my counter function, counter, and then we're going to print next c. Too many? Yeah, no, that was right. Okay, print next c, and we'll do this 3 times. And yeah, so this should print, if start is 0, this should print 0, and then 1, and then 2. Okay, save this, and then let's run gen.send. Okay, gen.send. Oh, generator object is not callable. What did I do wrong? Define counter start equals 0. N is start, while true, yield n plus equals 1. C is my counter, print C, print next C. Why does this look so weird? Hang on a second. There's like too many parentheses here. Print next C. Yeah, I don't know how I ended up with that. Do I have an open parenthesis somewhere or something? Print next C. Yeah, why is this angry? I guess we'll never know. Open, close, open, close. Give me the error. What is wrong? Invalid syntax. Print next C. Print. What happens if I just print C? Now I'm debugging their code. All right, so let's save this, clear this out. Generator object. Okay, so we got our generator object. And then if I want to print next C, I should get 0, right? And if I say, okay, this works, let's use this one instead. That gives me the same code, so I can get rid of this. And then I want to do this one, and it's all of a sudden, because I'm missing a parenthesis, and I need to go drink more coffee. I don't know. Now it's mad. If I delete this and delete this, print next works. And in my previous one, gen, print next, I was passing it the variable. Does it have a value? Oh. No, that should be right. So print next is 0, which makes sense, right? So this generator object would essentially run forever. You could keep calling it and it wouldn't stop because it doesn't have any sort of condition. But if you did want to stop it, we'd have to add something. However, I should still be able to get the code to work, unless this is theoretical. There we go. Oh, there must have been something. You can let me know if you see my problem, but I just deleted it and retyped it and it works. Okay, so yeah, I could just keep doing this and it will just keep going and going and going, and it will just do it as many times as you want. So in this case, what we would need to do is make some sort of stop, right? So let's do a file called preparation.stop.py. I can save these so we can look at them. All right, so stop is going to equal false. And then we'll say, all right, we want to define a counter, and it's going to have that start equals 0 again. Except this time, what we're going to do is we're going to say n is start, whatever the start value is, and then while not stop, which sounds funny, I know, yield n, right? Yield n, yeah. Yield n, and then increment n by 1. And then we can say c equals counter, and we want to print next c, and we'll do this twice. And then what we'll do after this is we'll change the flag stop is true, and then print it again. And this should raise a stop iteration. So let's try this. All right, so now we want to run Python gen.send preparation dot stop 0, 1, and then a stop raise stop iteration. Okay, cool. So that works. That seems to work out. So until you change it to true, the generator is going to keep going forever. But as soon as we changed it, you see it did raise a stop. So you can make it better, probably always make it better, huh? Let's see. We could say instead, how about instead of doing this, we'll say while true, and we don't even need this false thing, and we can just get rid of that too. We can say while true, results equals yield n, and then we're going to print the type result, comma result, but if result equals q, you'll see where I'm going with this, then break, and then we'll just increment n by 1, something like that. All right, so we do this, and then what I'm going to do instead is I'm going to go, we'll do a print next c. We'll use this one, and then I'm going to print c dot send. Wow, and we're going to send it something, and then we'll do a print next c, and then I'm going to print the next, or no, let's do print c dot send, and then we'll send it a q, a capital Q, and get rid of our stop exception because q will stop it. And we should get like something interesting. We should get a number, some result, a number, and then something else. So let's check this out. All right, so we got a 0, which makes sense because it starts at 0. And then it increments by 1. And it says while true, which is still true, yield result n, which would be 1, and print the type and the result. So we get 0, the class is a string, and we also get this. We're getting now this wow thing, right? So, and then we get 1 class none type none, and then 2 class string q, and we got a q. So it was like, uh-oh, and it broke out, and it does a stop iteration. So you can also stop it like that. So here's what's going on. So we start the generator execution with a call to next. Okay. Within the generator, n is set to the same value as start. So the while loop is entered, execution stops, and n, being 0, is yielded back to the caller. 0 is printed on the console. Cool. So then we call send in line 14. Execution resumes. Result is set to wow, and it's type, and we're still in here, right? We're still in here. So then it's set to wow, and then what happens? Well, let's take a look here. So the value is printed on the console. The result is not Q, so n is incremented by 1. Execution goes back to the while condition while being true. Makes sense. So it just keeps going through until it finally breaks. So you can use this to allow for some interesting patterns. It can also be used to start execution of a generator if you provide a call like with none. But anyways, I hope that makes sense, and we'll move on to some talk about yield.